make this as easy as possible for us. This section is 2.5. And we are talking about linear models. And in math, a linear model, a model is just an equation we use in order to find other stuff. Before we can get into that, though, we need to talk about correlation. Correlation, make sure I spell it right. Let's see, correlation is the strength of the relationship between X and Y. So for example, let's say I have a scatter plot, and when I plot all my points, all of the points are going in an upward direction, really close to being in a line. Okay? If they're really close to being in a straight line, we call this a strong positive correlation. As X goes up, Y goes up. Now, if they're still going in kind of a line up, so it's not quite so in a line, but they are going more in an upright position or upright angle, we're going to call that a weak positive.
Wait, why are those all spread out? Because it's like, it's where your points are going to be at, and it's like a weak positive because they're not all tied together.
Right, they're not really, really close to where we would draw our trend line. They're around it, but they're not like in a line exactly.
I get it.
All right, and again, this is the same. If it's positive, when X goes up, Y goes up. Let's say I have a scatter plot, and the points, when I plot them, are going in really close to a straight line, but going down. If it's going down to the right, this is a strong negative correlation. And if it's a negative correlation, as X goes up, Y goes down. Oops, sorry. Okay.
This seems pretty chill so far.
So far, I agree. If those same dots are a little more spread out, they're still going kind of in a negative direction, but they're not exactly in a line, so they're a little more spread out. We're going to call this a weak negative correlation. And again, as X goes up, Y goes down. And we have one last one to talk about. If when we graph it, the dots are all over the place, and they don't seem to be going in any particular direction altogether, this is no correlation.
Wait, so then X is never going to go down?
Well, when we think of X, it's as it's going to the right, so it's always going up, right? It's always getting bigger as the other one's doing something else. All right, so we're going to start with example number 1. Now, example number 1 is going to cover our 7 and 8.
Is this going to be in our books today or just on a worksheet?
It's in our books.
Okay.
And I have posted it in Google Classroom, just so you know. All right, so 7 and 8, it says, make a scatter plot and state the correlation. And let's see, let me give you some data. Say we have X and we have Y. Let's say X is 2, Y is 47, X is 4, Y is 43. Let's say X is 6, Y is 45. Let's go X is 8, Y is 39. So X is 10, and Y is 30. All right, so we've got to start by making a scatter plot. All right, on my bottom axis, I'm going to go by ones. 1, 2, 3, 4, 5, 9, 10. And on my y-axis, I'm going to do a break. So this is where 30 starts. And then I'm going to go by 5. So let's say 30, there's 35, here's 40, there's 45, and here's 50. All right, so let's start by plotting our points. Our first point is 2 and 47. So over 2 and up to 47. Now we have 4, 43, 6, 45, 8, 39, and at 10, we're going to 30. All right, look at this correlation. What do you guys think?
I like it.
What kind of correlation is it?
Oh, it's a strong negative.
Good. Strong negative correlation. Okay, that is all you have to do for the first two problems. Now, technically, what you would do next if we were going to write an equation is you would draw yourself a trend line through a majority of the, that's not what I want. Let's go with this one. You would draw yourself a trend line through the points as close as you can get, right? And then you would pick two of those points that fall closest to our line. Which 2 points would you guys say fall closest to the line?
30 and 10.
The 30 and 10?
47 and 9. I mean, wait. No, the 47 and 2.
There we go. Okay. All right. So those 2 points would fall closest to the line, right? So we're going to use those 2 points to make ourselves a line of best fit. So we have the point 247, and we have the point 1030. So in order to write an equation, we have to first find our slope, right? So 30 minus 47 over 10 minus 2. 30 minus 47 is negative 17 over 10 minus 2, which is 8. Does everybody agree so far? Okay. Then we are going to put it into point slope form. So I have y minus 47 equals negative 17 over 8 times x minus 2. Now, here's the last thing we're going to do today after you get your equation. I want you to predict y when x equals 18. So we're going to put 18 in for x and find out what y equals. So we have y minus 47 equals negative 17 over 8 times 18 minus 2. 18 minus 2 is 16. We're going to grab our calculators. Let's go. So on this side, I got negative 34. So I have y minus 47 equals negative 34. And then I add 47 to both sides. So I got y equals 13. Does everybody agree? Oh, that's definitely not 13. Let's try subtracting that again. Oh, it is 13. All right. Yeah. It's been a long weekend for me. Yes. Okay, now, listen. This is what we've done. We did it in Algebra 1. It's what we usually do. However, now that we're getting a little more mature, and we're finding linear models, which is a fancier way of saying line of best fit, we are going to use technology to write our equations. Okay?
Say you accidentally do the graph a little messed up, and you mess up on the numbers, and then the whole entire equation is done.
Right, I agree. That's why we're going to start using technology to do it. Okay? So I want to talk about technology writing our equation. So here we go. I'm going to give you a table to work from first. We're just going to say this is my x and my y. And let's say x is 1 when y is 7, x is 3, y is 11, x is 5, when y is 12, x is 7, when y is 18, and let's say x is 10 when y is 20. No. This is not an example. It's just part of, I'm going to talk you through the steps of what we're going to do. We're going to get our calculator to write our line of best fit from this table. Okay? Right what? Well, yeah, you got to put the table down. Okay? So here's what we're going to do. The first thing I'm going to ask you to do is go into stat. Your stat button on your calculator. Stat is right underneath delete. And then it goes down to edit. I want you to hit enter. Right underneath DEL. Right in the middle. There's stat. Go down to edit and hit enter. You're going to have some lists come up. You guys see list? Correct. We are going to enter our x values into list 1. And we're going to put our y values into list 2. Okay, hold on. I'm going to tell you. So, along with me, this is how you get rid of the numbers in the column. Go up and highlight it. Go up and highlight your L1 or L2. Hit clear and enter. Do not hit delete. Clear and enter. Yep, you got to go up to the L1 or L2. Clear and enter. Now all of your lists should be empty, and we can put all of our x's in list 1, all of our y's in list 2. Okay? So start by doing that.
Oh, wait, you said list y?
Space between them. I don't understand. You're in the list. No, you didn't go to the right spot. Hold on, I'm coming.
Right below del is stat.
Great, you hit stat. Go ahead and hit stat for me. Oh, yep. Yeah, you're putting them in here. So go ahead, hit clear. Oh, yep. Okay, go over to this one. Go up, hit clear and enter for me. All right, so now go back over to here, and we're going to put all of your x values in list 1.
What is that? What I do, 1 and then 2? Hey,
no. Okay, all of them, so like my list 1, I put all of my x values. In my list 2, I'm going to put all of my y values.
Oh, okay. Who you talking to? So, in this one, I put the whole entire top row, and then L2, I put the whole bottom.
Correct.
Okay.
What? Well, it's because you have to go over to list 2, go down out of list 2. You got to be actually, oh, go back in. Okay, so what did you do? Let's go back in. Oh, hold on. No, sir. Okay, go ahead and put your list 2 in. Please wait. Get your list 1 and list 2 in, everybody. All right. Okay. Now I'm going to ask you back into stat. Yep. I'm going to have you push once to the right to where it says calc. And go down to number 4 where it says line reg. Okay. And we hit enter. Hold on. And we hit, you guys listen. And we hit enter. It should come up with X list is in list 1. Y. It's doing it. Okay. When you did it, you should get X list is in list 1, Y list is in list 2. Then it says frequency list, stored list, and go to calculate. Go down to calculate. And when you hit enter, it gives you your equation. It says at the top y equals ax plus b, and it tells you what a is and it tells you what b is. So you get y equals 1.48x, and then my b value is 5.885. So it wrote the equation for me. All right? So you are going to have to do this for almost the rest of the assignment. So let's do an example. It isn't. Right, exactly. And if the calculator can do it, it's going to save you all that stuff. You said it was a lot of work the other way. This is just hitting some buttons, right? That's fine. I'll know. All right, so now we're going to go to example number 2 as soon as Matt's ready.
No, it's not. Because we should be able to finish this in class today. That's why I wanted her. She'll know. All right, we're good.
Okay. All right, here we go with example number 2. This is questions 9 through 11 is what we're going to do next. 9 through 11. Write an equation for the trend line. All right. And let's say our points are our points are 2, 6, 3, 9, 4.5, 13. And let's go with 6 and 16. All right. So we're going to do the same thing. You're going to put all your x values in list 1, all your y values in list 2. We're going to go back and find our equation. Okay, so grab your calculator. You're going to go back into stat, into edit. You have to get rid of the list that's there. So you go up, highlight it, clear, and enter. Go to the other one, hit clear and enter. Now put all your x values in list 1. And all your y values in list 2. Good. Then you go back into stat, over to calculate, and down to number 4. Good. If you did it right, you should have y equals 2.5x plus 1.299.
I still got it. Nope, I just did it. All I did was put a 5, 0.
Oh, that's fine.
Yeah, that's what I put too.
Yeah, that's fine. Wasn't so bad, right? Just 12. Okay.
It's all good.
Yeah. All right. So any questions? Okay. All right. Next one. Example number 3. Example number 3 is what you are going to do for 12 through 14.
How many do we got?
I've only got, this is my last example, and I'm going to talk about the last couple of problems. That's it. Okay, so last example, but you got to listen. All right. Find the linear model and use to predict the number in 2028. All right, so here's our table I'm going to give you. Our year is up here. We got a number down here. Let's start with, in the year 2000, I'm going to say we have 22. In the year 2005, let's say we had 28. In the year 2010, we're going to say we have 31. In the year 2015, let's say we had 32. And we'll do the year 2020, we have 37. All right, now, first thing we have to do is make a linear model. Now, there's something special when it comes to years. I need all of you listening. When you have years, you never put the whole year in. You always start with the first one as 0. So this will be 0. This would be 5. This would be 10. This one would be 15. This one would be 20. And then when I go to predict, what number would I be putting in? 28, exactly. Very good. All right. So now we're going to go back into stat. You're going to put in your x values 0, 5, 10, 15, 20. And then you're going to put your y values in. We're going to come up with a linear model as step 1. Correct. Okay, hold on. Let me catch up. Yep. Go ahead and tell me what you got, Parker. Okay. So you, yes.
Okay, so, wait, why do you guys get 28 and we need to...
We'll get there in a second, okay? So, we're writing a linear model, right? You got y equals 0.68x, and you have to put it that way. Parker, are you with me? Plus 23.2. This is my linear model or my equation. Now, it says to predict the number in 2028. But we don't put the whole year in. We're going to put in just 28 to represent the year. And I put it in for what? For x. Thank you, Kaylee. We put it in for x. So I have y equals 0.68 times 28 plus 23.2. So I go to my calculator. I type in 0.68 times 28 plus 23.2. And I got 42.24.
Okay, so why do you have to do this 28?
Okay, so just like when we put in our table and we only use like the 0, 5, 10, because we don't want to put a whole year in there because it's too big of a number. Okay, since 2000 represents 0, 2028, what number represents that? 28 years later, right? That's all it is.
So if I have a problem like that, I'll just times that after I get my answer with all the values. You know,
you just plug it in. You plug it in for x in your equation.
Okay. This is pretty easy, but someone else has a good question.
Okay, so listen very carefully. This is the first time we're doing this. We're going to learn from it. It's going to be fine. Okay? That's the whole idea is we're learning. Right. Yeah, it's not too bad. Once you get these steps down, this is going to be so beneficial. We're going to use this all year. We can actually write all kinds of equations from the same exact program, and we're going to be using it all the time. Okay? So that's the idea. We need to learn it really well right now so that we can use it and not have to think twice about it later. Okay? Now, the last 3 questions you have in your homework today, they are actually asking you for a correlation, but it's from words. So all I need you to say for 15, 16, and 17 is positive, negative, or none. Okay? So for example, let's say they said the number of hours you study and the score on your math test. Is there a correlation between those? Yeah, as you do more of one, does the other one also supposed to go up? So that would be a positive correlation. Okay? But what if I said to you the size of a hat and their IQ score? No correlation at all, right? Or if I said to you the size of their shoe and the number of friends they have? No correlation. That's all 15, 16, 17 are. So either say positive, negative, or none. Okay? All right. You have about 12, 13 minutes. All right, you might be able to get some of this calculator stuff done so we're all working together. You're welcome.